Hello student, how are you? I am Arun sir, qualification Bachelor of Engineering from Jadavpur University. Welcome to my channel Tuition Expert. Today in this class I will discuss you units and dimensions. Now let's start about the class. Quantity, any quantity, two types. Fundamental and derived. Fundamental units. So we have to put the units of fundamental and derived quantities. So fundamental units. Fundamental units, three types. SI, that is called international system of units. This is main units. We units of any quantities in terms of SI units. This is standard. And another supplementary units is CGS, centimeter, gram, second system, centimeter, gram, second system, and APS, which is foot, pound, second system. These are the units. Now, standard fundamental units. Important prefix. Important prefix. Some important prefix. Mega. Symbol is M. This is prefixes, and this is symbol and power of 10. This is denoted by 10 to the power 6 mega. Now milli, symbol M, so this is 10 to the power minus 3. Kilo, K, 10 Q. Nano, N, 10 to the power minus 9. Micro, mu, 10 to the power minus 6. Pico, P, 10 to the power minus 12. Fermi, F, 10 to the power minus 15. So these are the standard prefix we generally use in problems of physics. Mega, capital M, 10 to the power 6. Milli, small m, 10 to the power minus 3. Kilo, K, 10 Q. Nano, N, small n, 10 to the power minus 9. Micro, mu, 10 to the power minus 6. Pico, P, 10 to the power minus 12. Small p. Fermi, small f, 10 to the power minus 15. So these are the important prefix generally used in problem of physics. Now some important units. Astronomical units. 1 AU, which is equal to mean distance of Earth from Sun. It is the distance between Sun and Earth. We take mean distance because distance of Sun from different places of Earth will be different. So we take the mean distance. So this is value is this. So 1 AU, it is a astronomical unit and it is the unit of distance. And second, light year, it is the unit of distance equal to distance traveled, okay, distance traveled by light in vacuum in 1 year. Light year, 1 LY is equal to this. So this is the value is. Now next, parsec. These are the important units. Parsec. It is not unit of time. It is the 1 parsec equal to 1 which is equal to LY. LY means light year. 1 sec. One sec. 10 to the minus 8 second. 1 bar. Unit of pressure. Newton per meter square, which is equal to 10 to the power 5 PA. PA means Pascal. 1 torr. 133.3 Pascal. 1 horsepower. 746 watt. And 1 pound. Unit of mass. 453.6 gram. These are the important units. What is angle? Suppose we know angle between two lines is measured this way. This is the angle. We written a angle. We write a angle at here. Suppose this is 60 degree. Now the 60 degree is what? Is 60 degree is this length, or it is a this area? What? What is 60 degree? That is, what do you mean by 60 degree? Is it this length, or is that area? Now if a student mark this, then this length will be different. This, but all are same angle. And if he mean that this is area, then that area, this area, the angle. If angle is actually the two ratios of two length. This is a arc length and this is a length. This is radius. Suppose this is S1, this is R1. This is S2, this is R2. This is S3, this is R3. So angle is defined by ratio of two length, S1 by R1, S2 by R2, S3 by R3. So this is the angle, definition of angle. S1 by R1, S1 by R1, S2 by R2, S3 by R3. This is the angle. So as we increases the length from that point, then arc length also increases. The ratio will be same. Then that ratio is called the angle of that angle between two lines. This is the angle between two lines. Suppose this is O and OB. What is radian? Now it is the plane angle. It is the plane angle between two radii. Between two radii of a circle which cut off and on the circumference an arc length of equal arc length equal in length of radius. So what is radian? Suppose a circle. So this is a part of, suppose this is a part of a circle. This is a part of a circle. Now if this radius is r and this is also r, then this angle is called radian. That is the circumference, length of the circumference, length of this part on the circumference will be equal to length of radius. Then that angle is called radian. And if we increases the length, suppose this is r, but if we increases that value, this is not equal to r, so that this angle is not called radian. So to find the radian, we have to determine the length of this circumference is equal to radius the length of the circle should be equal to radius of the circle, then that angle is called the radian. Now what is this? Is plane angle. Now plane angle is denoted by theta equal to arc length. This is s by r, plane angle. Now what is solid angle? Now solid angle unit steradian. It is that this is three-dimension figure. Suppose this is a cone and this is a vertex. That angle. So it is not a area. The angle, solid angle is not a area or a volume, and also not that angle. This is a three-dimensional figure, so we cannot assign the solid angle area, volume, nothing. So what is solid angle? Solid angle is, suppose this area is a and this radius is r. So solid angle equal to, denoted by steradian, equal to area by r square. Area of that. Area by definition of solid angle. The steradian. What is the definition of steradian? Definition of steradian. What is the definition of steradian? Now this is the solid angle. Solid angle which having its vertex at the center of sphere. At the center of sphere, cut off an area of the surface of sphere equal to that of a square with sides of a square. Now of a square with sides of length equal to that, to the radius of the sphere. This is called steradian. So steradian, this is the definition of steradian. So solid angle is denoted by. Now let's discuss how to find the dimensional formula of some physical quantity. For that, we use some symbol of some fundamental quantity. Suppose mass is denoted by m, length is denoted by l, time is denoted by t, and current is denoted by ampere, temperature denoted by Kelvin or sometimes theta. So this is the quantity. Now we have to use this symbol. So how to find the dimensional formula of some physical quantity? This is a physical quantity. We have to find the unit of this physical quantity, and now this is dimensional formula. Physical quantity. Suppose we have to, suppose force unit is Newton, but Newton, what is Newton? The formula of force equal to mass into acceleration. So mass is kg and acceleration is meter per second square. Now from that we can find the dimensional formula. Kg is denoted by m, meter this is a unit of length, so l. Now second square, this is time square, so m l d square. Now dimensional formula is written within a third bracket, so we have to use this third bracket. That's why we find the dimensional formula of any physical quantity. This okay, okay. Suppose work done, W. What is the formula of work done? Work done equal to force into displacement. Force equal to MAS. So its unit is joule or arc. That is mass, acceleration meter, per second square into displacement. S for displacement. Displacement is meter. Again meter. Mass is kg. A is meter per second square and displacement is meter again. So this is denoted by m. Kg is mass. Meter is L square. D square, that is m L square to the power minus 2. So this is written as within third bracket. So this is written within third bracket. This is the dimensional formula of the water. Suppose momentum. Momentum means mass into velocity per second. So kg is m meter L by t equal to ml to the power minus 1. This is written as third bracket. Now what is the dimensional formula of angle? Suppose any angle theta, we know s by r, ratio of two length s by r, that is s is length, l is length, so angle is dimensionless. So this is written as n0 l0 t0. Angle is power if p equal to work done by time. First write with formula, then work done equal to force into displacement ma into s by t. So dimensional formula, mass is m, acceleration is l by t square, s displacement is l again by time is t. So this is ml square to the power minus 3. So this is written as third bracket. Torque. Torque equal to force into displacement, force into perpendicular distance between two force. This is torque. So force is ma and force into perpendicular distance. So yes, so force. So m is m, acceleration s is l. This is written as this. Within third bracket. So that's why we find the dimensional formula. First we write the formula, then we write the unit, then we put mass is m, length, that is meter, is this is mass, length is l, and time is denoted by t. And if we require the current, then we use in place of current ampere A, and temperature is theta or K. We use this symbol. How to convert from one unit to another? Suppose 1 joule. This is the SI system of water. How many of arc? 1 joule. We know 1 joule equal to 10 to the power 7 arc. Now how to find? By dimensional process. 1 n into u equal to constant, where n is a numerical value and u is the corresponding units. Suppose 1 joule, this is a SI system. Water 1 joule is the unit of water in SI system, and arc is unit of water in CJ system. So suppose here N1, this is a one system and this is another system. Now water, now write the dimensional formula of water. Water equal to, now write the dimensional formula of water. Now we know water equal to force into displacement, mass into acceleration displacement, that is m l t to the power minus 2l, which is m l square to the power minus 2. So we use this formula. So m1 into m1 l1 t1 2 is m2 l2 t2. Now we know unit of time in any system is second, same. Now we know the units of time of any system is same, that is second. In unit of time in all system is same, unit of time in all systems are same. So now n1 equal to 1 joule. So this is 1. We have to find the n2. Now this is a mass of SI system. This is mass of CGS system. So we know mass of one system is 1 kg, length is 1 meter, and this is second. Mass in CGS system is 1 gram, is 1 centimeter. This is second. So this cancel. Now we have to find n2. Now n2 equal to 1 kg, 1 meter divided by 1 gram, 1 centimeter, 1 meter square, 1 centimeter square. Now 1 kg equal to how much gram? 10 cube gram. 1 meter means 10 square centimeter. That's square. So what comes? This comes 10 cube to 10 to the power 4, 10 to the power 7. So value of n2 is 10 to the power 7. This is the answer. This is the answer. So 1 joule equal to 10 to the power 7 R. That's why we convert from 1 unit to is homogeneity of an equation. This is a very important topics of dimension. From that principle, we have to determine the unknown quantity, dimensions of unknown quantity. So, what is suppose the equation is this? That is, this equation tells that homogeneity of an equation tells that the dimensions of both sides of a physical expression, the dimensions of both sides of a physical expression will be equal. That is dimensional formula of this, dimensional formula of this, and dimensional of this are equal. So two important points we have to remember. Dimensions of both sides of an equation are equal. Second thing is the quantity of same dimension, quantities of same dimensions can be added or subtracted. Quantities of same dimension can be added or subtracted. This, if the dimensions of this quantity and this quantity be same, then we can add this. Because from common sense, we know 5 kg plus 3 kg, we can add. Both is mass, so we can add. But we cannot add 5 kg plus 3 meter. We cannot add because these are two different units. This is unit of mass, this is unit of length. So we cannot add. So if we can add or subtract, expression has greater than or less than inequality, greater than or less than inequality. Suppose this is greater than inequality. So for that also the dimension of this and these are same, and the dimension of C and D are same. Also the dimensions of A, B, C, D all are same. So if the expression is greater than or less than or equal to, then the dimension of all the quantities in an expression will be same. Now, so dimensions of X, Y, W, V are same. So from that principle, we can find the dimension of unknown. Now let's discuss about some problem. Find the dimension of A, B, C, D Suppose first question. These are the equations. We have to find the dimensions of A, B, C, D from that equation. So you use the solution. Solution of one. What is the principle or property of dimensions equations? Dimensional equation. Now we can add the same. We can add the quantity of having same dimension. We can add the quantity having same dimension. So dimension of x is equal to dimension of A. So A equal to dimension of x, which is equal to L. Now mass here 0 times 0. So we can use this. Now these dimensions of both sides of an equation equal to same are equal. Dimensions of both sides of an equation are same. So also we can add only same type of dimensions. That is dimension of all these, dimension of this, dimension of this, and this all are equal. So BV dimension equal to this dimension equal to dimension of x equal to dimension of b. So for the quantity in a physical expression, the quantities in a physical expression should be equal dimension. This is the property. Quantity of a physical expression have the same dimensions. So from that dimension of x is L, so BV, that is dimension of b equal to x by v, that is, so this is the dimension of b. Velocity dimension of velocity is L by t, meter per second. Velocity dimension is meter per second. Unit of velocity is meter per second. So L by t. Okay. Equal to dimension of A equal to dimension of this. This is the principle. So dimension of A will be L. This is dimension of A. dt equal to x. So b equal to x by t. So dimension of b equal to L by t. That is m0 L t minus 1. Now dimension of b we get dimension of ct square. So c b plus a, we can now third b plus a into this. Third, the dimension of a will be equal to dimension of b. As we know, we can add only a quantity having same dimensions. So the dimension of a must be equal to dimension of b. We can add only quantity of having same dimensions. So dimension of a should be equal to dimension of b. Now this is T for P is pressure, and here P is volume, and T for temperature. This is gas constant, R gas constant, and N is mole. So we don't record these dimensions of this quantity from that. So dimension of A equal to dimension of P. Now pressure equal to, what is pressure? Pressure equal to force by area. So force equal to M. Dimension of force equal to this. Area is L square. This is the answer. Now B is subtracted from V. So dimension of B should be equal to dimension of V, that is L cube. So that's why we can find that x equal to a this. Now here x is in meter, even x is in meter, C, T for time, T is time. Now uh, this is angle, this is angle. So what is angle? Angle is dimensionless quantity. Now we know the same quantity having the quantity having same dimension can be added. So dimension of D equal to dimension of T, which is equal to T M0 L0. This is the dimension of D because T is added to the time. So dimension of D will be equal to dimension of T. Now the ratio will be unity dimension. This is dimensionless quantity because angle is, this is theta, this is angle which is dimensionless. So dimension of C should be equal to dimension of time. So C dimension will be dimension of time, that is T. This is dimensionless quantity. So dimension of D must be equal to dimension of T because D is added to the T and the whole is dimensionless. So dimension of C should be equal to dimension of T. Now this is a value. This is a numerical value. We know sin 30 degree equal to half. So this is a numerical value. Now the dimension of X should be the dimension of A. So dimension of X will be dimension of A. So dimension of A equal to dimension of X, that is dimension of A will be X, that is L. So this is the answer. Dimension of A, so dimension of A is this, dimension of C is this. Now next step is how to derive the formulas. Suppose time period of a physical pendulum is, we know the formula is, this formula we have to derive by dimensional formula. So you are giving that time period of a simple pendulum, time period of a simple pendulum is proportional to length and acceleration due to gravity. So time period is proportional to length and also g. Now what will be the power of length and power of g? We don't know. The power of length and g have to be found by the dimensional analysis. So time period, this factor you are giving, time period is of a pendulum is proportional to length you are giving. So T equal to K into L to the power A T to the power B. Now first we take in this form. What is K? K is a constant. K is constant. You the experimental value of K is given 2 pi. Now you have to find only the A and value of A and B. So this is the dimension of T, length L, G. What is G? G is the acceleration. So acceleration we know L T square. So this is L T square. L to the power minus 2. So this is whole to the power B. That is L to the power A plus B to the power minus 2B. Okay. So we know dimensions of both sides of an equation are equal. Of both sides of an equation are equal. So we here L is 0 and M is also 0. Here M is 0. So A plus B should be equal to 0 and minus 2B equal to 1. Dimensions should be equal. So power of A plus B equal to 0 and power of minus 2B, here minus 2B equal to, here power is 1. So from this we get this and A equal to minus B, which is equal to half. So we get the formula twice by 2 bar L. L to the L. L to the power A. A is half. And G to the power B. B is minus half. So we get this is the formula of time period of a physical pendulum of a simple pendulum. So this is the time period of a simple pendulum. Students, subscribe my channel to get more videos. Now this is the end of this class. Okay, thank you.